Well, this is boring. I'm going to sleep.
All right. 5F. So the quick little picture is banana.
Was that on purpose?
I think so. I can't remember. It's the same practice that's used for a long time. Oh. So the top. So first off, okay, 5F. We established that we want to use which method? Yeah, we want to use shells. So I can preserve the dx, right? Washers would require me to do dy. I don't want to do dy. So I just do the shells. So do you see that's not why, but that certainly seems to be an explanation as to why there are two methods. Whatever one method can't do, the other one should be able to do. Blah, 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 blah. So I point out that x squared, this guy is on top here. And so the bottom dude is going to be 2x squared plus 3x plus 10. Sorry, no. Plus 2. So if I'm going to use shells, I'm rotating around this line. So how would I draw in a representative rectangle? Would it be like that? Or would it be like that?
Parallel to the x-axis.
It would be along in which direction? In the y direction. It's got to be parallel to the axis I'm rotating.
Oh,
so
yeah.
if I draw in
Yeah.
Parallel to
the axis I rotate around. Yeah. How do I locate that rectangle I just drew, though,
X.
on the x-axis? That's why it's dx. Things make sense. There are ways to just memorize things, but you should have it backed up by why the hell does it make sense that it's that way. All right, so this is x. So the immediate question was, all right, you're being very patient. I just asked one thing. What's the radius? So how do you get the radius? You start from the axis and you draw out to your representative rectangle that you drew. He just wants to be part of the calculus.
X minus 2.
No. It's the big dude. X is the bigger dude, right?
Right.
Minus the smaller dude.
And if the small dude's a negative, it's plus the small dude.
There you go. So I think you said it right. So the radius would be x plus 2. Go away, red. So it's, what's the form of it? The volume element would be 2 pi
R H.
r
H.
h, sure, dx. So the radius is this. What's the h?
The top minus the bottom.
I like it. So it'll be, let me make a little room here.
X
So
squared
2
minus 3.
pi, r is x plus 2. Yeah, exactly. So when you do these go away, you get negative x squared plus 4. And relative to the other, this is the nicer one. There's only 2 terms in each. I have to every now and again give you a problem that's a little bit more. So you remember why algebra was important. So is this cool? And the rest of it's on there. But that I really want you to understand. How do you find the radius? Always, like we just did. No matter where the hell things are, don't try to make too many cases. Well, if it's on this side of the y-axis, I've seen people do that. No, the bigger one minus the smaller one. You go out from your axis, right? You go out until you get to your rectangle. You draw bigger one minus smaller one. Right. So if I was rotating around 2. And this is my rectangle here. Or let's put it in the same place. There it is. So what's this?
X.
X. What's the bigger one?
2.
2. So if I go out there, it'd be big minus small.
Bam.
Right? Is this distance more than 2? The way I've drawn this exact X where it is this more than 2?
Yeah.
Of course it is. And why does it make sense? If this is negative 1, that should be 3, and it is. 2 minus negative 1 is 3. So you can give yourself a specific situation, like always. Just to make sure that what you've written makes sense, right? Alright, so this is not a bunch of disconnected little steps in this big process that you can never understand. This is every step actually should make sense. And you should have a way to make sure that you're on the right track. Cool. So I love this. What does all this represent? What does all that represent? The what of the what?
The
The
volume.
volume of the
Shadow.
rotated shape. It's not the shell. The shells are the pieces of the volume. I want you to be real careful. So if I rotate this, I get this shape. It would be the volume of that shape, right?
Banana bowl.
The banana bowl. You need one of those. The weird thing is, I have a bowl in my office that one of my ex-colleagues, who thank God doesn't work here anymore, gave to me, and I just keep it just to remember how big the dorky was. Yes, I just said that out loud, and I don't mind it, because it was. You needed to go, I'm sorry.
And it
Oh,
was
shit.
a banana.
That looks like this. It's got an open bottom, so I'm like a bowl with a hole in the middle. Thanks for that. But I think he gave it to me for this specific problem. Maybe I'll bring it in, but remember. Say, look, there it is. There's the banana bowl. Right? So your bananas just fall right through.
Like
that's
a
a good
banana
thing.
phone.
Are you guys?
Yes.
And the rest of that is on the answer key course. And after that, it should be easy. That's so weird.
Who's weird?
That's awesome. Sorry. So, I mean, if you rotate this thing, it actually won't be quite the right shape because it's right on the axis. The bottom of it's got a hole, so this wouldn't really work.
He's on the two
But
axis.
it'd be like a thick, there's a bowl in the middle, I agree with you, it's a bowl, but it's the thick side because it's got this thickness to it. Do you see that? If you rotate this region around, it'll have that thickness to it. Right? Section 8.2 would say, let me just rotate one of these curves around, and then I get a thin bowl. It's only got that, there's no thickness to it. I don't know if you guys understand. That's enough of that. Sorry, it's beyond what we really need to do, but okay. So 5E leads into 5G. Is that the question? Yeah, because I don't have 5G on the answer key. 5E, for those of you who tried it out, is kind of long and involved. I didn't put all the little minutia of it on the paper. You with me? If you look at the answer key, I just go from one step to the next. Like, bam! Don't do that on the test. Right? This is an answer key, so I'm actually showing you a lot more than I really need to. How would 5G relate to 5E? So let's look at 5E real quick. What am I rotating around in 5E?
The Y. Or E. The X-axis.
5E, yeah, the x-axis.
Yeah, the
So I got my banana. Oh my gosh. There's a
We got ran over.
there's a drought here.
It's always a bad here.
Well, in California, it's true. And we're rotating around the x-axis. This would be more like the bowling alley. So that's for 5E, right?
Yeah.
So, and this one, I want this to be integral, what was this one? Yeah. I don't want to solve for y, I want this to be integral dx, right? And I'm rotating around the x-axis, so which method do I need to use? Washers, right? I don't have the option. I can't use shells even if I really wanted to, unless you actually want to figure out how to solve that quadratic for the other variable. How are we doing so far? All right, so in 5E, the inner radius and the outer radius are very well established because I just start from 0. So it's whatever the hell that is and whatever the hell that is. Is that cool? And I think the top one was the x squared one. So the outer radius should be related to this, and the inner radius should be related to the 2x squared one, right? So the only difference with 5G would be all the same exact kind of work, except my inner and outer radius are now in relation to
Y.
No, I'm sorry. 5G was around y equal -2. Where's y equal -2? Draw it in the air for me. There it is. Y equal -2. I'm going to rotate around this. So now all my radii used to be this big. They're going to be how much bigger? They're going to be 2 bigger. Yeah, that's all. And again, that still holds. Here's I'm doing washers, so I don't do a little rectangle, right? But if I go from this to this, that's going to be, this is the bigger one, that's the smaller one, right? So the inner radius is going to be the 2x squared thing, blah, 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 minus -2, so plus 2. So you just add 2 onto the inner and outer radius that you got from 5e, which is just the functions themselves. So 5g is exactly the same work. So if you don't want to do 5g, I don't blame you. at least be able to set it up though. You know, on the actual test, I'm not going to give you one that's just a bunch of multiplication until you go insane. I really won't. But I think I had a reason for that. I just want to remind you guys, hey, look, it's not always nice. And some of you guys are like, no, is it ever nice? Was my question.
On 2C, at the end of it, when you have 0, so it's 1/3 e to the 2 minus 3x to the third, I got that same thing, but when you have 0, it's still e squared. What happened to the e squared?
Let's see, what did I do? Yeah, it should be plus 1/3 e squared. I don't know why I dropped off the e squared.
Oh, okay.
Yeah, I just dropped the e squared off. So on 2C, it should be... I don't know why I did that. 2C, it should be negative 1/3 e negative 6 plus 1/3 e squared. Because when you plug a 0 in, there's still a 2 there. I like it.
I'm so happy right now. It didn't take like 5 tries.
So 8.1 and 2 are extra credit.
Yes. So on the test, if I put a question on it, it's going to be in the bonus section.
Will there be any like Riemann sums?
Like number 1?
Well, like more like the ones where you're
that.
xi. Okay.
You'll notice, well, let me think. Yeah, that's missing. I think that's all that's really, really missing from here. I mean, so the whole idea of the Riemann sums and the knowing the summations, you have to see that, but I'm not going to continue to dredge that back up.
I'm very happy about that.
In Math 280, for those of you taking Math 280, you're going to learn some really cool techniques like the trapezoidal method. So instead of making rectangles, you make trapezoids, because if you think about it, trapezoid should fit the line better, because it's making a little line that fits the line there. I don't know if you guys understand.
Yeah.
So the midpoint, you make the actual line, and then you make a line out from that following the curve. So you'll learn how to do that easily.
Do you cut it in half somehow?
Somehow. Yeah, you just take the average really, but it'll be built into the function. And then that enables you to do things like, maybe you don't have a function, maybe you just have observations you've made over time, and you have to integrate that. So if you take observations of the temperature of a lake over time, if you integrate that, you'll get the total heat that was put into the lake or taken out of the lake. But you only have observations, you don't have a function. But that's what's the beauty about Riemann sums and things. They only use certain function inputs, don't they? We don't even need a function. That's not enough. Sorry, I'm bringing in stuff that's in your future because I just was filling a void. Now
Looks like we're pretty close to done with practice test. So on question, I can't read this question. Question 30 on 6.3, it doesn't like meet the line anywhere. It never touches the line, so I don't really have a region to rotate because it's 1 over 1.
6.3.
Yeah, question 30 on 6.3.
The one that they want you to figure out what the solid is, right?
Yeah.
Yeah.
But it's 1 over 1 plus y squared, so it doesn't really reach 0, does it? It doesn't touch the line.
Started half of it. Goes equal to 5. 0, 2.
By the way, tomorrow I'm going to bring a little worksheet with a few examples of shells, washers, discs, just to kind of focus on during class. You know what I'm saying? Because today I was hoping we might be able to get to where we are right now. So tomorrow I can bring in this little worksheet, because normally that's what people really want some more practice with. all the situations that you run into with shells, washers, discs, the radii, what could happen. So we'll do that. That's why I like the idea of 2 days of review, which I'm sure you guys were fine with also.
Yes.
So number 30, it says, so this is the shells section, and they say, can you figure out what, somebody set this up from some given situation, can you figure out what the situation was? So what do shells normally need? What goes in here?
Well, they need a
Let's say
radius.
dy.
First, they need a radius.
Radius?
And they need two functions subtracted from each other.
So
No,
it would be
thinking about,
it would
well,
be y.
sort of. Not necessarily, but yes, I understand what
It
you're
would be
saying.
y for the r, and then h would be 1 plus y.
Yeah, so this is related to f, in this case of y, but
R would be
or two functions if I have two, so I have to take the difference, but does it look like that's what happened here?
No.
You could actually work it so that it did, but let's not do that. You might be able to tell there's going to be possibly several answers. But the main answer to get, what's one way to kind of pull apart the inside so it looks a little more like that? What's the simplest way to pull that apart?
y times 1
Yeah,
over 1
y
plus y
times
squared.
1 over 1 plus y squared. Right, so there's your radius. So I'm starting at the x-axis going out. Right? So, and this is shells, this is dy, so I must be rotating it around where?
Yeah.
Yes, like the x-axis possibly, or something parallel to the x-axis.
Yeah.
Right? So here's my represented rectangle. Usually I would draw it floating in space because I actually don't know what the function is yet, but I actually kind of do. This has to be the height. And since we're interpreting it to not be the difference, because you could possibly interpret it to be the difference, because if I have a top part and bottom, but if I just interpret this to be this minus 0, so this side would be this minus 0. That would be the height of that rectangle. Do you guys see that? It's not the only way to do this. But
How did you know that, like, y should be the radius and 1 over 1 plus y squared should be the height?
to get this to be the radius would, again, I almost want to say it's impossible, but in general, not really. For us, yes, that would be impossible, because we're always doing it, rotating around something parallel to the x-axis or parallel to the y-axis. So at most, it could be x minus something or y plus something like that. There's no way I can get a function like this unless I'm rotating it around a curve, which is not impossible, but for us it is. We keep it there. Somebody had a really good question about, we do it around here, why can't I do it around a diagonal? Well, you totally could, all day long, you totally could. You just have to know how to rotate your problem, which is interesting, right? Anyway, sorry. So this looks like it would be the radius. This looks like it would be the height. So now if you draw this, that's kind of one way to answer this question. Give me a drawing. Yeah, there you go.
Or it doesn't touch the line, that's what I'm confused about. Because it doesn't have a region, because it never reaches 0.
No, but, so it's just going to be, what do I want to say here? So if you do this, the smallest that could be is 1, that output. So for y equals 0, you get 1. So yeah, you got it drawn right. So it looks like that. It's asymptotic there, right? The smaller, what do you think? The bigger y gets, the smaller this gets, right?
Yeah.
So as y gets bigger, either direction gets smaller. And it's going from 0 to 2. So they just took this region here. That's, oh, I see, that's why I think it's got it. They just took this region. So that's like saying, so right there, y equals 2.
Okay.
So we've done that before. I mean, we've had this thing. Is that touching? No, but if I rotated it, then I would just say it's like that and then rotate that region, right?
Yeah, because I thought there was no intersections to those.
I got you. No, but it's just drawing that line. It's the
Infinitely
boundary of that region is that line on the top. Cool. I didn't understand what the problem was until I'm like, oh, I see. But that you just draw the line.
I thought it
Holy
was going to be
crap,
like
that's
a hill that stretches out forever. And I was like,
Totally does. Thank God they closed this in. All right. So So tomorrow, like I said, we'll focus on that worksheet. And anything else you want to request we focus on tomorrow? So I can build it in?
Maybe
I knew that discs and washers and shells would be big.
questions where you have two functions intersecting each other, but you have to like
Oh, change,
figure out
do different intervals?
functions.
Okay,
Some of them
sure.
are just-
All right. Yes. Amy?
Yes.
Hey. What's up?